Hello, everybody. My name is Max Ryabinin. I am a senior research scientist at Yandex Research and a PhD student at the HSC University. And today I'm going to cover a topic of decentralized deep learning at a large scale. So the subtitle is Running and Training Large Neural Networks Together. So first, let me give you a bit of background here. So probably most of us know at this point that large language models like GPT-3 or ChatGPT or Llama, for instance, can solve many natural language processing tasks basically out of the box. You can present to them the context of your problem by means of natural language, and they will be able to respond to your request, well, depending on what you ask them, with varying degrees of success. Or as an additional setting, you can give them a few examples of what they need to accomplish in order to solve your problem. And this has been shown to improve the results in such cases. And recently, in 2022 and 2023, we've seen that many large language models got released into the basically into the open source. One of them is Bloom by Big Science. Another one is a family of OPT models by Meta, and there are like others which keep being released like every month, basically, or every couple of months. But the difficulty with using such models on your own hardware is that it's difficult to run them at reasonable speeds without multiple high-speed accelerators, which basically means GPUs. So if you want, like as a rough, very napkin math thinking, if you want to use such model on your GPUs, it will involve 8 times RTX 3090 GPUs with 24 gigabytes of memory, or 3 times 800 GPUs, which have 80 gigabytes each. This is for an 175 billion parameter models. So, and obviously these resources are not available to everybody. So we need to somehow solve this problem, and ideally want to democratize the usage of such large models in order to make them useful for everybody. So one of the possible solutions, which is frequently used, is offloading. The basic idea is very simple. You can load the weights of your model onto your RAM or simply onto your hard disk drive or SSD, which has a lot more storage than GPUs, but obviously this incurs an additional bottleneck for transferring the weights of your model between for each iteration of your generation procedure. So this is what makes it slow for interactive inference. So if you want to have like an assistant or something that gives you fast responses and not like one response in several minutes, you need to come up with another solution. The second option is also, I think, pretty well known at this point, and it is hosted APIs. So most of the companies that serve large language models now, they make them available via those APIs that make you as the user send a request to the company, and then it's possible to get a response from a server on which this model is hosted. So this is a solution which is very easy to use, obviously, because you just need to send a request. But for many reasons, it's not as flexible. Basically, the model is not available to you at all. And well, it can cost money depending on the economic model of the API provider. So in our research, we've been focusing on using volunteer resources and using large collaborations for such deploying workloads. And one of our latest works, called Petals, is precisely the solution to run language models across collaborations of volunteers in a style that can be compared to BitTorrents. You can visit the website even right now to check out the details, but please stay with me a little bit longer. I'll describe to you the gist of the techniques behind Petals. So our approach is on a surface level very simple. As some of you might know, the language models of today, like Bloom or GPT, are usually composed of many sequential blocks. So what we do here is load the blocks of each model on some blocks of the model on the GPUs of some of the participants. So some people serve the first one third of the model, some of them serve other parts of the model. So these participants are called servers, and they allow others to basically run all sorts of computations that are required to make the model work. And another group of participants, which can overlap or be completely disjoint from the first one, is called clients. And these are the actual people who do some meaningful work with the language model. They perform forward or backward passes through the entire system by sending requests in as predefined like route to the servers that they pick. So the routing strategy can be dynamically chosen based on the availability of those servers. And as we show in our experiments and both in real deployments of Petals, the speed up can be actually quite substantial compared to what you have with offloading using your own GPU, but this slow hard disk drive. And compared and in case of Petals, we can have like 5 to 20 times speed up depending on your local hardware performance. So in the first case, you need to send hundreds of gigabytes of parameters over the GPU bus, and in the second case, you need to send megabytes of intermediate model activations over the internet. But that's not all. Because the model is transparent to you in this case, you can actually adapt or fine-tune the model for your own task. Imagine that I want to adapt Bloom to a new language, or to do RLHF or do any sort of fine-tuning on my problem of interest. So there are methods that allow you to do this locally without affecting the entire set of parameters. And this is what, in my opinion, makes Petals especially useful. As I mentioned previously, the code base of Petals is openly available. The GitHub repository is on the website, but below you can see the collab, a notebook that shows you how to use it in practice. So the interface is very similar to what people do with Hugging Face transformers, because we mostly rely on abstractions from existing libraries. And as another example of the application of Petals, we've developed a very simple chatbot style website called Petals Chat, which allows you to talk to Bloom, or in this particular case, Bloom Z, which is an instruction fine-tuned version of Bloom, over this decentralized network. I think right now we're experiencing some slight downtimes of the network, but I think we'll be able to get it up and running at the time of community discussion. So our two major projects for work in progress are rewards for hosting servers, basically just incentives that you will be able to exchange for high priority requests. And obviously another issue is data privacy and security in the public forum. Right now you can deploy Petals on your local, on your private infrastructure, and the data will be completely private. But right now it's theoretically possible for intermediate peers to have a look at the activations of your neural network. And also, as another method, also in the same vein, I wanted to really briefly describe swarm parallelism. This is the same approach, but for training large models over the internet. So the key observation here is that the compute costs of your model grow faster than the communication costs if we arrange the network in this sort of a pipeline. So this observation can make training large models feasible on relatively slow networks. Here I've given the number of 500 megabits per second, but it can be pushed down even more. And as I described previously in the case of Swarm, we can use this for pipeline parallel training from scratch. But this obviously requires a lot more hardware resources. So at this point, I'd like to invite everybody for the discussion and just briefly overview what can be done by serving some parts of this decentralized deep learning systems on BOINC. So I think at this point, we have a pretty vibrant community, which is mostly focused on Petals, on HiveMind and other projects around it. But sadly, the number of peers, even at this very moment, who are actively serving some layers of Petals, can be very low, because, well, not everybody knows about this technology, not everybody has the means to set up a platform easily. And I think this is where the expertise of the BOINC community can be very useful to us. So, like, as one suggestion, it would be very interesting and, in my opinion, pretty great for the entire machine learning community to design a system that would allow BOINC peers to join the public swarm of Petals, or to have like a separate swarm specifically dedicated to BOINC peers. As far as I understand, well, and I have arguably a limited understanding of how BOINC particularly functions, one of the constraints here previously was that we required peer-to-peer communication between servers that host the model. But actually, with some of our latest developments and with existing technologies, it might be technically possible to route the communications, basically all data transfer, between over some set of predefined relays, basically. So this would be the servers that only need to do communication and no computation. So I think here I would just like to briefly conclude by saying that, in our opinion, and as evidenced by our work in the collaborative deep learning field, this decentralized approach can be an alternative to clusters or to supercomputers, and open libraries actually allow you to adapt the existing workloads pretty easily. Some of the ongoing challenges right now are the security, incentives for people to participate in such projects, and support for more operating systems and for broader ranges of hardware in general, for instance, Windows or AMD GPUs. And well, that concludes my talk, and I'm very curious to hear your thoughts on this approach.
Well, thanks, Max. That's super cool. So we'll ask people to use the hand raise feature if you have questions. In the meantime, I guess I have one preliminary question as to, you mentioned, the data transfer requirements for a participating host. Can you characterize both the bandwidth and how much data a host would be expected to transfer in a day or a week or a month or something?
Yeah, let me just reshare my screen for a moment, because I somehow switched to the next slide. So actually, it depends largely on the, yeah, I think let's stay here. I think that largely depends on the constraints that each peer has, because obviously, even with the traffic, the daily traffic of like 1 gigabyte per day, it can be still very useful for the entire system. Basically, if we estimate the size of intermediate like communication buffers to be like tens to hundreds of megabytes for any single request, and if we multiply that by the number of tokens, like 50, so this gives us a good estimate of like like slightly under a gigabyte in some cases, but obviously that can increase for like more requests, and actually the communication load can be pretty high in this case. So I'd say that it's substantial, but it's possible to use throttling, for instance, to basically drop out of the network as soon as you exceed the limits.
Okay.
Yeah, and I didn't mention the latency, right? Sorry
Correct.
for interrupting. So I'd say that it depends mostly on which use case you have in mind. So if you want to have a really interactive system, it helps to have low latency, like under 50 milliseconds, I guess, or like around that. But if you want to make your particular node useful for fine tuning, in this case, you don't need to have like low latency. So even I guess seconds would be tolerable in this case, as long as the clients know that, well, this is the high latency peer. So if you increase the timeouts, it can be the latency can be pretty high, as long as like the client is satisfied.
Okay. And is there a minimum GPU spec? So for instance, at the beginning, you showed GPUs with 24 gigs of RAM. Does that apply by Petals?
Not really. So yeah, and to be very precise here, you can see that at this moment we serve three models, all made available by Big Science, which is a very like large open collaboration in ML. So one of those models is a 7 billion parameter one, and this this is mostly used by people as a playground. So if you want to just try serving some parts of like Petals, you can really quickly connect to Big Science Bloom -7b1, and the model will be very small. So for larger models, I'd say that a reasonably size GPU starts from around 8 gigabytes of memory, which is a lot more like realistic and a lot more widespread. So if you have like an 8 gigabyte GPU or a 12 gigabyte GPU, which is like most mid-level gaming GPUs at this point are, then you can connect to Petals without any issues, and you will be pretty useful for the public swarm. So I'd say that it's starting from 8 gigabytes and from the Pascal generation of architectures. So like 1080 and like newer models.
Okay, great. Next question is James. Let's unmute James.
Okay, can you hear me?
Yeah.
Yeah, Max, it's interesting. So you set up 1 gigabyte. I mean, it's been our experience with large data downloads, and I can tell you that from Gridcoin's experience dealing with lots of BOINC participants, it's the VirtualBox implementations that seem to give people a lot of trouble because they're very big downloads to pull the virtual machine down, and those can sometimes be quite large. But you know, if you can get the data flow down to the medium level like you're talking about, I think there'd be people that would be interested. I mean, a gigabyte a day might give some people some grief. So I mean, the question is that an absolute lower bound, or is there a you know, or can you get even lower than that?
Yeah, I think that for serving requests on a particular, like on a single machine, I'd say you can go much lower than that. Yeah, thanks for the question, by the way. But we can do like we can think of several alternatives here, basically. So one of them is to rotate the GPUs of, well, rotate the participating nodes based on their data transfer budget, basically. So if we have I don't know, like 1,000 participants, and well, only like most of them are only capable to donate a gigabyte of uploaded traffic once per like several days, then we can adjust the group size of people who are like simultaneously serving Petals and basically spread it out over several days.
Yeah, I think it's all over. I think when you look at the realistic participants out there, it's all over the map, right? I mean, what we see is, and we've got thousands of different participants. We see people with GPUs all over the place. You know, I've got a 4080, which is pretty meaty. It's got 16 gigabytes of RAM. You know, you're right that most of the average GPUs coming out now are 8 to 12. You can't, it's hard to get something over 12 unless you're going to spend a lot of money. And then the older generations, you know, if you don't get a 1080, the older ones are 4, right? And maybe 6. And so you definitely have got this spectrum. So, I mean, you know, it's not like you're going to be windowing yourself out by choosing what would be regarded by most people as pretty high-end requirements, but it would narrow the set of participants that would be able to do that. And that can get irritating to the community, right? A lot of people get very upset if they want to participate and then they find out their hardware is relatively new and still not good enough, right? So you got to think about perceptually what that looks like in the community.
Yeah.
But, yeah, I mean, it seems like you can reach downwards enough to get a good number of people participating. One last question too on this: how do you validate people's work? I mean, one of the biggest concerns when you incentivize is the worry that people are going to cheat, you know. And so what Gridcoin requires for many of the projects that participate and where we incentivize, we require multiple work unit validation, right? Cross-checking against each other. And my understanding is with machine learning, that's quite difficult, right? So, you know, how do you make sure that people aren't messing with the calculations they're doing or otherwise invalidating the work that you're trying to do?
Yeah, this is also a very good question. I have to say that, well, at this moment, since we have no incentive mechanism, well, that maybe explains the number of peers we have in the network right now, but still. So at this point, we have no incentive mechanism, and thus we haven't developed the validation scheme. But Alex, who is actually the lead developer of Petals, has suggested the following approach. If you recall my talk, here we are serving already pre-trained models. So we do not expect the weights, the parameters of the neural network that is served over Petals to change over time. So one layer of Petals can be downloaded by several people, and in practice, the computations will be nearly identical. So, or at least we expect them to be nearly identical. So what can be done here is simply, if you want to validate the outputs of a particular server, like somebody in the middle of Bloom, you can just run it through one person's GPU and run it through another person's GPU. So,
Okay,
and if the results...
Yeah, so basically what you're saying is you can really do a wingman approach. You can actually essentially give the same work to multiple participants effectively using the same parameter set as an input. That makes sense. Yeah.
Yeah, that's correct.
That's
so
good. Yeah.
And
Great.
well, based on the amount of malicious participants, we can adjust that on the fly.
Cool.